Alright, welcome to lesson 11. Today we're just going to be continuing to work with numbers in scientific notation, adding, subtracting, multiplying, and dividing them, and comparing them. So let's go ahead and jump right into it. Alright, just to build some background before we move in, when we multiply numbers in scientific notation, we multiply our numbers and we add our exponents. Here's an example right here. Okay, pretend these are numbers written in scientific notation. We would actually take A and see what those numbers are, multiply them together, and then we take our exponents, B and D, and we would add them together. When we divide in scientific notation, we do pretty much the same thing except we subtract our exponents. So we would divide our numbers, A divided by C, whatever that comes out to, and we would take our exponents and we would subtract them. Adding and subtracting is a little bit more difficult because we have to have the same exponent in order to do it, so sometimes that requires an extra step. So the first step is to make sure our numbers have the same exponent. If you look over here, they do not. This is a 2 and this is a 3, so you have to make one of them either a 3 or the other one a 2. In this case, they made this one a 3, so they added 1. That means that they moved this back one space to make it one space smaller. Okay, now that they have the same exponent, they can add the numbers like regular, and they keep that exponent. All right, and that is how we also subtract. So let's go ahead and move into some practice. All right, this first example says the U.S. national debt as of March 23rd, 2013, rounded to the nearest dollar, is this huge number. According to the 2012 census, there were about this many citizens. What is each citizen's approximate share of debt? So if we were splitting this debt evenly between all of these Americans, are we going to be adding these numbers, dividing them, multiplying them, subtracting them? Well, the key word here is split. We're splitting it to this many citizens, so we're taking this number and we're dividing by this. Okay. First thing you need to do is write your number in scientific notation. This first number right here is 1.6, and then we have to keep every single one of these numbers. 7, 5, 5, 1, 3, 3, 0, 0, 9, 5, 2, 2, times 10 to the, how many spaces did we move? We moved 3, 6, 9, 12, 13 spaces. Okay? And we are dividing that by this number, which is going to be 3.13914,040, or 0, times 10 to the 3, 6, 7, 8 power. Okay. And our rule for dividing with scientific notation is we divide our numbers like regular, and then we are going to subtract our exponents. Okay. Let's do this in our calculator real quick. We have 1.6755, 133, 009, divided by 3.13914040. This comes out to, in my calculator, 0.5337, blah, blah, blah. I'm just going to round it to 0.534. It's okay to round at the last step. I didn't want to round up here because we still had to do some math. And 13, take away 8, 8, 9, 10, 11, 12, 13 is 5. So we have this number, 0.534 times 10 to the 5th. It's asking us what is each citizen's approximate share of the debt. We could write our number in scientific notation if we wanted to. We would just need to move this over 1. This becomes 5.34. And if we made that number bigger, we make this smaller. Or we could actually write our number out as an expanded form number. So 534, move this 1, 2, 3, 4 spaces. So that means that each American's approximate share of debt is $53,400. And that's our answer. Please make sure you have it down before we move on to the next one. All right, exercise 1, it says the mass of a proton is this tiny number. Go ahead and write that number in scientific notation and pause this video. Or pause this video, write it in scientific notation, then play it again to check your answer. Alright, your answer here should be 1.622 times 10 to the, we're going back, 3, 6, 9, 12, 15, 18, 21, 24, 27, 27, that's where it stays. And we went back, so this is a negative 27th, okay? Below it says the mass of an electron is this. Go ahead and pause this video, write it in scientific notation, and then play to check. All right, we want our leading digit to be right here behind this 9, so this is going to be 9.10938.291 times 10 to the, we're going back 3, 6, 9, 12, 15, 18, 21, 24, 27, 31. So the negative 31st power. All right, so these are the two numbers we've written in scientific notation, just kind of practicing writing them when they're very small numbers. Okay, we're going to work with these on the next slide. All right, it goes on to say, write a ratio that compares the mass of the proton, so we're comparing the proton to the electron. A ratio is just a fraction, guys, okay? So our proton was 1.672, 622 times 10 to the negative 27th. Our electron was 9.10, 938.291 times 10 to the negative 31st. Okay, so there's our ratio. And then it goes on to ask us below, compute, that just means calculate, how many times heavier a proton is than an electron. So it says find the value of the ratio. Basically, it's just saying divide. Okay? We are going to divide our numbers, and we are going to subtract our exponents. All right? So go ahead and do that in your calculator. Pause this video, and then check your answer. All right, when you divide your numbers, you should get, I believe, 0.1836159. Okay, and then when we subtract our exponents, we're doing negative 27 minus negative 31. It's the same as saying keep, change, opposite. Negative 27 plus 31. Well, 27 plus 31. Negative 27, sorry, plus 31 is going to give us 4. All right, from there, we're going to either write this in scientific notation and leave our answer in scientific notation, so that would be, the decimal would be right there, 1.8361529 times 10 to the, we made this one space bigger, so this would be one space smaller, 10 to the third. Or we can write our number completely out, which in this case would be moving this 1, 2, 3 spaces. Okay, and that's what I think I am going to do. We have our final answer down there, and it says round it to the nearest 1. So our 1's position is right here. So this is 1,836. So about 1,836 times greater. The mass of a proton is about that much times greater than the mass of an electron. Okay? moving on. All right, the geographic area of California is 163,696 square miles. And the geographic area of the United States is 3,794,101 square miles. Let's round off these figures to these numbers right here. And in terms of area, roughly estimate how many Californians would make up one U.S. Okay, showing how many times does California fit into United States. So let's just see, here's the United States, right here. Pretend this is the United States, there's Texas and then California, okay? And we're seeing how many times does California fit into the United States. So we're dividing it. We're dividing the United States by California. So U.S. over California. Okay. For the California, it was this number and they rounded it to this. 1.637 times 10 to the 5th. And for the United States, it was this big number and they rounded it to this in scientific notation. 3.794 times 10 to the 6th. Go ahead and divide these numbers and subtract your exponents, please. Pause the video and then check your work. All right, when you divide these numbers, you should get 2.317654525. Okay. And when you subtract these exponents, 6 take away 5 is 1. Right? It says, roughly estimate how many Californians would make one U.S., compute to the nearest ones. So it actually wants us to write this number out and then round it off. So it is already written in scientific notation. I'm going to expand it, so I'm just going to move it that one space that's indicated right here. So this is actually 23.1765425. And then my question told me to round to the nearest ones. That's my ones position, so I look back. That 1 is not going to make me round up. It's going to just stay at 23. So about 23 Californias would make the U.S. All right. Go ahead and make sure you have that down before we move on. All right, exercise 6, it says the average distance from Earth to the moon is about this, and the distance from Earth to Mars is that. On the simplistic level, how much further is traveling from Earth to Mars than Earth to the moon? So Earth to Mars is further, obviously, than Earth to the moon. We're trying to figure out how much further. So we're trying to find the difference. So we are subtracting these numbers. Okay, let's go ahead and fill them in with what they gave us. Earth to the moon is 3.84 times 10 to the 5th. Okay, and Earth to Mars was 9.24 times 10 to the 7th. All right. Our rules for adding and subtracting is we have to first make sure that our exponents are the same. They are not the same right now, so we can either make them both 7s or both 5s. It's completely up to you what you want to do. I'm going to make them both 7s, so this one's going to stay the same. And this one is going to become 10 to the 7th. Now I increased this by 2, so this is going to go back 2 spaces. Two spaces smaller. So this is going to be 0.0384. Okay. From there, we subtract like regular our numbers. We have 9.24 minus this. We'll do that in our calculator. All right, you should have come up with 9.2016. we keep the same exponent we had, 10 to the 7th. Okay, now we want to actually write our number out. How much further is traveling from Earth to Mars and Earth to the Moon? We want the actual number, so we're going to move this 7 spaces. So this becomes 1, 2, 3, 4, 5, 6, 7. 92,016,000 times greater. Okay? Or more miles. Or kilometers, sorry. It's in kilometers. That's our number written out. All right, let's move into your practice. All right, here are the ones I want you to do on your own before you move into the exit ticket. Number 1, there are approximately 7.5 times 10 to the 18th grains of sand on Earth, and there are this many atoms. Are there more grains of sand or atoms in the human body? How do you know? So really look at these two numbers. You don't even have to do any computation. You can look at your exponents and explain that. Number 2, how many times more atoms in the human body are compared to grains of salt? So you're going to do atoms divided by grains of salt. Write them in scientific notation and then find your answer. Next one, the geographic areas, blah, blah, blah. Okay, you are taking this respective area. Nah, actually, I'm not going to have you do number 3. I'll cross number 3 off. It's too much. Too long. And number 4, the actual population of the U.S. is this. Nope, don't do that one either. Just do 1 and 2, and then we'll come back together and check, pause this video, and then you can move into your closure and reflection once you feel confident. All right, at this time you are checking your work. You should have solved these two. First one, you should know that this, the number of atoms is greater than the sand because our exponent is to the 27th power and this is to the 28th. Or sorry, to the 18th. Okay. From there you were dividing these numbers, the number of atoms divided by the number of grains of sand. So it's going to be 7 times 10 to the 27th over 7.5 times 10 to the 18th. When you divide those numbers, 7 divided by 7.5 in your calculator, you get 0.93 repeating. And when you subtract your exponents, 27 take away 18, you get 9. If you were going to write this number out in scientific notation, it would be 9.33 times 10 to the 8th. We made this number bigger, so we make this one smaller. Or if you wanted to write it out in expanded form, it would be 1, 2, 3, 4, 5, 6, 7, 8. 933 million. Okay, hopefully you got those correct. If not, maybe cycle back through, see where you went wrong. Okay, we're going to go ahead and move into our exit ticket and closure. Alright, to just close out this lesson, when we are multiplying in scientific notation, we multiply our numbers, add the exponents. When we divide the numbers, subtract the exponents. When we add and subtract, first have to make sure they have the same exponent. Once they do, we add or subtract like regular and keep our exponent. The other thing I want to point out is writing numbers in expanded form, answering a question. You just move that decimal point as many times as your exponent indicates to write your number in actual expanded form. Let's go ahead and look at our exit ticket. All right, here is your exit ticket for today. It will be posted in Galileo, so please do it there. Take your time. You're doing pretty much exactly what we've done today, so look back through the lesson if you need help with anything, if you need a little refresher, until you feel confident and ready to do your exit ticket, okay? And then when you finish, do your reflection as well.